Okay, guys. So the main thing on these, where you're looking at a graph to identify the variables, and then kind of explain what's happening in the graph between the variables. So first of all, to identify the variables, all you have to do is read the axes, read the vertical and horizontal axis, identify the variables by reading axes, right? So right here, the variables in the first one are time in days and gas in gallons. This is in a car. So variables are time in days and gas in gallons. And then explain what's happening at various points. Well, at first, gas is decreasing at different rates. Right here, the gas remains constant, and so you could do this. You could label these with numbers or letters, and you could say at interval 1. Right? You don't have to use the numbers. You could just kind of explain anyways, but either way, if you label it, the numbers can kind of help you be more specific. At interval 1, gas is decreasing, right? It's going down at different rates, so it goes down slowly, then quickly. Still decreasing, though, at different rates. Then, at 2, gas remains constant, and at 3, gas decreases again. So in short, you're using the axes, right? The vertical and horizontal axis to identify variables. Second, use words like increasing or going up, decreasing or going down, and constant when it stays the same, when it stays flat. These aren't the only words you can use, but just kind of giving you a heads up on some of the more common words you'll see. So in the next one, the two variables are, somebody's blowing up a balloon. The two variables are time, probably in seconds because they're blowing up a balloon, and the volume of the air in the balloon. So the variables are, again, time, most likely in seconds, and air volume, in the volume of the air in the balloon, right? What's going on here, right? Well, without necessarily labeling intervals, there's points on the graph where the air is increasing, and there's points on the graph where it's remaining constant. So the points where the graph is increasing are where volume is going up. You can word this however you like, just one example of how you might answer it. Volume is going up, volume remains constant on the flat parts, and the balloon pops, right? Volume goes down to 0 right at the end. Balloon pops at the end. Volume equals 0 at that point. V equals 0. Carrying on here, in this next one, I know the print quality is bad here, but this is board length, right? And this is time down here, right? So time and board length. So it looks like somebody is over time cutting a board, right? So your variables. Look at the axes. Your variables are time and length. Time and length, and I'm just gonna say with time passing, more cuts are made. So again, with time passing, more cuts are made. This could obviously be more detailed, but not too much space here, so you could make it more detailed. I'm gonna just chime in verbally on some of these. On this one, I know this print quality is bad, but the variables are minutes, how many minutes of calls, how many minutes I spent talking on my phone per se, and then over here the cost. So if, again, variables, minutes of calls, and cost. And you could explain this graph by saying at first minutes are increasing, but cost is remaining constant. And then it reaches a point right here, where the cost starts to rise with the minutes, right? So again, at first, minutes are going up, moving to the right, but cost is staying constant. And it reaches a point where minutes are going up and cost is going up together. Okay guys, so sorry about the print quality, but either way, moving on to these next kind of problems, and for the answers on the other ones, just check the pictures. But these ones give me a graph, and they want me to kind of match a graph to the table. Like, here's the table, number of days and total downloads. So again, didn't print, but this is days, right? 1, 2, 3, 4 days, and then number of downloads is the other column. So if you read it, it says a band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown? So here's what you have to check on for something like this. You have to check if numbers or data, check if data is increasing or decreasing at a constant rate. Right, so one thing you can do is that. Second thing you can check for is, does it ever reach 0? That might be a good thing to kind of notice or keep an eye out for. Does data ever reach 0? So these are just some thoughts to kind of figure it out. So if you look over here, you can see this data. It goes up by almost 700, then it goes up by almost over 2,000, then it goes up by like 7,000. So moving along here, guys, since the data is not going up at a constant rate, it's not this one. This one's going constant. This one's going down, and then so it's got to be either C or B. It's got to be B or C. And what you notice is B kind of is going up, up, up. It does start rising pretty quickly, and then C starts rising quickly, but then starts to flatten out. So this data continues to rise faster and faster. So it is going to be B, where B, over time it starts to rise faster and faster. It's definitely not the ones that are constant movement, and it's not the one that flattens out, C. So this one's B. Again, because the data rises almost by multiplying by 3. It's almost tripling, right? So data is almost tripling, or downloads, right, each day. right? So if it's tripling, it's not constant. Again, that's got to be B. This next one's talking about a bottle or a can of sunscreen. Yeah, can of sunscreen, right? When it's brand new, it has 5 ounces. After 1 use, it has 4.8. After 2 uses, 4.6. After 3 uses, 4.4. And basically what you hopefully would notice here is that it does, after each use, it decreases by the same amount. It's decreasing at a constant rate. So the graph should be going down, but also at a constant rate. So it should kind of look like a line. So again, if you notice, it's going down by 0.2 ounces each time. So look for one that's going down. They're all going down. Look for one that's going down at a constant rate. This one looks like a line. This one looks like a curve, not a constant rate here. So it's not this one. It's not B. These are A, B, and C again. Sorry about the quality, but it's the dots are showing the data, and it's, you know, number of uses, right? First use, second use, third use, fourth use, and how much sunscreen is left. Notice after the third use, there's still a lot left. It doesn't go all the way down to 0. Like A goes all the way down to 0, basically. So constant rate of decrease, but doesn't go down to 0. It's got to be C, guys. So again, that was a constant rate of decrease, ends at, let's just say, greater than 0. Right? It's constantly decreasing, rate of 0. This is not constant. This one goes all the way down to 0. It has to be C. And then at the end, you can see the dots, you guys, but so I went ahead and filled in the data since it didn't print properly. But either way, you're trying to match graphs in 3, 4, and 5. You're trying to match this data to the correct table. If you look at the graph for 3, the data goes from the first data point, it goes up, and then up a little bit, then down. The fourth one goes down kind of a lot. It doesn't go down at a constant rate, that is. And then 5 goes down, but at a constant rate. So let's see here. Let's see which data shows up, up, then down. This one just goes down, not constant though. At the end, it's not constant. This one goes down, pretty much, if you notice, at a constant rate. And then this one goes up, up, then down. So the one that goes up, up, then down is graph number 3. Again, it's up, and then down to 21. In number 4, we have data that goes down, but not at a constant rate. It kind of starts dropping pretty huge at a certain point. So, well, I guess this would be, you know, not that much. Then it goes down a lot. Then it goes down a lot more. So we only have these 2 left. It goes down, then it goes down by 2 degrees, then by 8 degrees, then by like almost 20 degrees. So it looks like this one, you can double check. This one just goes down by 1 degree every time. So this is constant. So graph number 4 has to be A. Graph 4 matches with A. Graph 3 was matching with C. And so obviously graph B should match with 5, but you should double check. It does match though. Look at 5, it goes down at a constant rate. You can tell because it makes a line basically, and then look at the numbers. They go down at a constant rate. So this is number 5.